The next module is section 1.8, absolute value inequations and inequalities. Absolute value are these symbols right here, and the definition of absolute value is the distance from 0. So in this case right here, when I say the absolute value of something is equal to 3, this number right here is the distance from 0. So if 0 was my marker right here, and I wanted to go 3 in this direction, or 3 in this direction, both of these would have a distance of 3, and so in this case, positive 3 is a distance of 3 away from 0, and also negative 3 is a distance of 3 away from 0. So since there's nothing in the middle of this with the x, the two answers that would make this true, or the two numbers that are a distance of 3 away from 0, are x equals negative 3 and x equals positive 3. Some other situations I can have with absolute value are greater than, less than, or in this case I did less than or equal to. And all of these, again, are related to the number 3. So we already know in this case that the two numbers that would make this exactly equal to 3 are negative 3, which is a distance of 3 away from 0, and positive 3, which is a distance of 3 away from 0. In this case, I want my distance to be greater than 3, so I'm going to take these numbers here and shade this way, and these numbers here and shade this way. Because if 0 is in the middle, and this distance right here is 3, and this distance right here is 3, then this is more than 3 away, and this is more than 3 away. So the interval notation for that would be negative infinity to negative 3, and then sometimes we say union or and 3 to infinity. For less than or equal to 3, similar idea. The two numbers that make this equal to 3, a distance of 3, are negative 3 and 3. This time we want it to be less than. So if this distance right here is 3 and this distance right here is 3, we're talking about the numbers that are in the middle. Since this problem says less than or equal to, we can also include our boundary points of 3 and negative 3. So the inequality for this one would look like this. When dealing with absolute value and inequalities, they like to throw us this loop right here. So remember, this right here is our distance. And the thing about distance is we cannot be negative. So a distance has to be a positive number. So in this case, we can't have a distance of negative 3, so this one would have no solution. And the last weird case is if our distance was everything but 3. So in this case, they're saying the distance can be any number except for 3 away. So if we think of a number line, what we're saying is, if this is our magic number 0, we can't be 3 away in this direction, and we can't be 3 away in this direction. So we can't include 3 here, and we can't include 3 here, but we can go everything past 3, everything in between 3 and negative 3, and everything to the left of 3. So in other words, we're talking negative infinity up to negative 3, don't include negative 3. Negative 3 to positive 3, don't include positive 3, and 3 to infinity. So this is like saying all of the numbers are possible except for negative 3 and 3. So when it comes to solving an inequality with an absolute value or an equation with an absolute value, we're going to treat it just like what we did before. So remember, this part right here is our distance. So in this case, we're thinking about having some sort of distance here, and we're going to go a distance of 6 in this direction, and we're going to go a distance of 6 in this direction. So if I want a distance of 6 in this direction, I'd be at positive 6. And if I want a distance from 6 to the left, I'd be at negative 6. So we're going to take this part of our equation, and we're going to set up two individual equations. So one of them would be 2x plus 1 is negative 6. So we're going to make this little marker right here be 2x plus 1. And we're going to go a distance to the left, which would be negative 6, hence this equation, 2x plus 1 is equal to negative 6. And then we're going to do the exact same thing to the right and have 2x plus 1 is equal to positive 6. When we solve these two equations, we're going to get the two numbers that we can plug into this equation, which will be a distance of 6 away from the origin. So in this case, we're going to subtract 1. And get 2x is equal to negative 7. Dividing by 2 gives us x is equal to negative 7 halves. On this side over here, we're going to subtract 1. And we get 2x is equal to 5. Dividing by 2, x is equal to 5x. And those are the two numbers that when I plug them into here, I will end up with a distance of 6. Meaning, if 2x plus 1 was equal to negative 6, that would be a distance of 6 away. And if 2x plus 1 was equal to positive 6, it would be a distance of 6 away. So looking at another example, same idea. In this case, this is our distance over here. So this distance is 10. So we're going to have some arbitrary marker. We're going to go a distance of 10 in this direction. That would reach us to positive 10. And we're going to be a distance of 10 in this direction. That would be negative 10. And then this marker is just going to be the equation 3 over x plus 1. So we're going to set up two equations. 3 divided by x plus 1 would equal negative 10, or 3 over x plus 1 is going to equal positive 10. Now these are both those examples of rational equations. So we don't like the fact that it says x plus 1 on the bottom, so we're going to multiply both sides by x plus 1. On the left side, the x plus 1's cancel, and we're left with 3. On the right side, it doesn't cancel, and we have negative 10 times x plus 1. Distributing the negative 10 gives us 3 is equal to negative 10x minus 10. Adding 10 to both sides gives us 13 is equal to negative 10x. And dividing both sides by negative 10, we get that one of our solutions is negative 13 over 10. Doing the same thing on this side, again, we don't like the x plus 1, so we're going to multiply both sides by x plus 1. When we do that on the left side, the x plus 1 cancels. That's how we do that. We're left with 3. When we do it on the right, it does not cancel, and we have 10 times x plus 1. Distributing, we get 3 is equal to 10x plus 10. We're going to subtract 10 from both sides. We get negative 7 is equal to 10x. And we divide both sides by 10. And we get that the other solution to this absolute value equation is negative 7 over 10. It is very common for absolute value equations to have two answers as the solution because there's two different directions that we can go into. So quite often we get two different answers. The next example of this problem can potentially be kind of confusing because there's an absolute value on both sides. So try not to overthink this. In this case, we're going a distance this way, and we're going a distance this way. So if this was 6, this would be positive 6, and negative 6. In this case, we're going to go a distance this way, and that's going to be 5 minus 3a. And we're going to go a distance this way, and that's going to be the opposite of 5 minus 3a. So just like we said, if it was a 6, it would be a positive 6 and a negative 6. We're going to go a positive distance of 5 minus 3a, and we're going to go a negative distance, which would be the opposite of this. Well, if I go the opposite of negative 5 minus 3a, that gives me negative 5 plus 3a. So we're just going the opposite direction. So both of those are going to be negative. So we get two equations again. 7 minus 3a is going to equal this side over here, which is negative 5 plus 3a. Or 7 minus 3a is going to equal this side over here, which is exactly like you see it, 5 minus 3a. Solving on this side, we're going to add 3a to both sides. And we get 7 is equal to negative 5 plus 6a. And add 5 to both sides. And we get 12 is equal to 6a. Dividing by 6, we get a is equal to 2. On this side over here, when I add 3a to both sides, I have 7 is equal to 5, because the 3a's cancel on both sides. I know that 7 does not equal 5, so this is not a solution. So the only answer for this problem would be that a is equal to 2. So when you stick 2 into both of these equations, it will make both of their absolute values equal to each other. Finally, when we see an absolute value problem where the absolute value part, which is this part right here, is not by itself, this is not necessarily the distance. So whenever we're talking about absolute value with distance, the absolute value part, which is the part that's in those little bars, has to be isolated. So in this case, we have to add 7 to both sides before we finish this problem. So we're going to have the absolute value of 15 minus 5x is actually going to equal 20. So here's our 0 marker. We're going to go 20 in this direction, and we're going to go 20 in this direction. And our marker is 15 minus 5x. So the two equations that we're going to set up are going to be 15 minus 5x is equal to negative 20, and 15 minus 5x is equal to positive 20. Solving on this side, we're going to subtract 15. And we get negative 5x is equal to negative 35. We're going to divide by negative 5 and get x is equal to 7. On this side over here, we're going to subtract 15. And we get negative 5x is equal to 5. And we divide by negative 5. And we get x is equal to negative 1. And those two answers would make this equation right here equal to each other.